Hello, everyone, and welcome to the live stream of the Virgin Orbit Straight Up mission. We are so excited to be with you here tonight in the studio, live from Long Beach, California, just down the street from our Virgin Orbit manufacturing plant. My name is Allison Packard. I'm your host for this evening. I'm joined in the studio tonight with my Virgin Orbit co-hosts and rocket scientists, Alex and Keith.
Good evening. My name is Alex Poveda. I am the lead mission design engineer here at Virgin Orbit. My team selected where our aircraft, Cosmic Girl, is taking off from today, the path she's taking to get to our drop point. We selected the drop point itself, and then we designed the trajectory that our rocket, Launcher 1, is going to fly today to take our customer satellites to their orbit. I'm here today to give you a background on our mission, to describe the mission itself, and also to give you a status of our current countdown to launch.
And I'm Keith Vanderputten, Senior Manager of Guidance, Navigation, and Control here at Virgin Orbit. My team determines the course that Launcher 1 flies and steers her into orbit. Today, I'm going to be your eyes and ears into the Mission Control Center, providing updates along the way to keep you informed as we proceed through launch. So far, as a quick update, we are disconnecting from all of our ground systems from Launcher 1 and prepping to taxi. So with that, let's go back to Allison in the studio.
Thank you so much, Keith. Now, I wanted to share with you a little bit about our purpose. Here at Virgin Orbit, we're on a mission to provide access to space in order to help improve life on Earth. Now, because of our unique air launch system, we're able to help small satellites get into orbit that help expand the potential of scientific research, education, climate observation, and business needs. And that all starts with our 747 airplane, Cosmic Girl. Alex, can you tell us a little bit more about the star of the hour?
I sure can, yes. So our launch system actually consists of our aircraft, Cosmic Girl, and of our rocket, Launcher 1, and a set of trailers that we call our ground support trailers. We're going to put a little graphic up on the screen about our aircraft. So our aircraft is Cosmic Girl. She is a Boeing 747. She came to the Virgin family back in December of 2001. She has actually flown over 2 million passengers and has over 66,000 hours of flight. She's flown 1,000 plus more than 1,000 flights out of JFK. So she is destined to be one of our aircrafts here because of her name, Cosmic Girl, that she already had before we got her. Next is our rocket. Our rocket is called Launcher 1. It is a two-stage rocket, both Stage 1 and Stage 2. Our Stage 1 engine is a Newton 3, is the name we gave it. It has a maximum thrust of 77,000 pounds, and then it's going to burn for 3 minutes today. Our Stage 2 engine we have called Newton 4. So Newton 4 is going to have a maximum thrust of 5,000 pound force today. And it's going to burn for approximately 6 minutes. So the total burns from Stage 1 and Stage 2 is going to result in a max velocity of 17,500 miles per hour today. Also, we have our ground support equipment. So these are a set of trailers that are mobile. It's part of what's unique about our system. So we have our aircraft, Launcher 1, and these trailers. First, the power trailer provides power to our rocket until it goes on its own. And then we have our fuel trailer that provides the fuel to the rocket, which it's already done its job today. We have a liquid nitrogen trailer that's keeping everything cool. We have gaseous helium that's making sure we're getting the right pressures in the right places in our rocket system today. We have the gas that's providing the various gases that our rocket needs for launch today. We also have gaseous nitrogen that's providing pressures in our rocket today. And then, of course, we have our liquid oxygen. We also have conditioning, which is making sure that our flight computer and other electronics on the rocket are staying at the right temperature. It can get pretty hot in Mojave and it can also get pretty cold. And then finally, we have our interface trailer, which helps facilitate all of our ground support equipment connecting to our rocket. Now, as Keith just mentioned, we're unhooking all of that because we're getting really close to taking off today. So we're going to show you some shots of the area and some video and little pictures and some video. So we'll be right back with some more.
Hey everyone, and welcome back. Alex, can you tell us a little bit about why we're launching at night this time?
Sure, yes. So we're actually launching at night this time to practice. We're practicing this for our next flight. So this particular one, there's no requirement that's requiring us to do it at night, but on our next flight, our customer has a requirement. They call it local time of ascending node. So the satellite is going to pass the equator as it's going in its orbit, and they want it to happen at the same time of day every time it passes it. And so in order to do that, we have to launch at a very specific time. So for the time that they want that to happen, it means we have to launch at midnight for where we're launching from.
Amazing. And we'll be carrying 7 payloads into orbit tonight. Can you, for those that may not be initiated, define what a payload actually is?
Yeah, you might hear us a lot tonight say payload, and so what we're referring to is our customer satellites. So a lot of engineers will refer to that as payload. So you'll hear that quite often tonight. Yes.
Great. And is there anything you're most excited to see this evening?
Well, I do want to state a little bit something about what we're doing with the satellites, is that we're taking them to a 500 by 500 kilometer orbit at a 45-degree inclination. So this is going to be probably only the second time that a launch vehicle has taken a payload to a 45-degree inclination from the West Coast, because it's normally very difficult to get around the land masses. But since we're able to fly out, we're able to do that type of trajectory and just do a turn, we call it a dog leg, later on. So that's something I'm excited to see us do again for the second time. And again, just getting that customer payload to their orbit.
Very exciting. And I believe we have some footage from Mojave. Would you like to see?
Sure, let's show that.
Okay, we'll be right back. Welcome back. Coming up next, we have an interview with one of our Virgin Orbit customers. Please welcome Lieutenant Colonel Belts of the United States Space Force. Danielle, please take it away.
Thanks so much. Hi, everyone. My name is Danielle DeVoy, and I'm a Senior Mission Manager. With me today is Lieutenant Colonel Justin Belts, who is the Chief at the Small Launch and Targets Division. Welcome, sir.
Hey, thanks, Danielle. Good to be with you.
Sir, can you tell me a little bit about your role, please?
Yeah, so I'm the Program Manager for the Rocket Systems Launch Program, which is the Space Force's small launch capability. And I lead about 85 folks of the Small Launch and Targets Division. We're part of Space Systems Command, which is one of the 3 basic building blocks of the Space Force called Field Commands. And our team is located at Kirtland Air Force Base in Albuquerque, New Mexico, and Hill Air Force Base just outside Salt Lake City, Utah. And our role is to put missions on orbit for the Space Force.
Wonderful. Can you please tell me a little bit about how your team at RSLP and STP work together?
We work very closely with the Space Test Program to design missions and then find the best launch solution. So the Space Test Program runs a forum called the Space Experiments Review Board, or SERB, And that forum brings a whole bunch of stakeholders within the Department of Defense together to pitch ideas for new experiments. And that forum decides which ones will get funded. As those experiments are kind of being built out, the Space Test Program packages them into individual launches, and then we work with them to find the right launch solution.
It's cool. So how do you and STP decide which missions you're going to package together?
Yeah, so really it's a function of which missions are ready at a given time. We tend to structure our missions about 1.5 to 2 years before flight. And so really it's a function of which payloads are going to need a launch about 18 to 24 months down the road.
Great. So how does using an air launch system such as Launcher 1 help you and the Space Force meet your goals?
Thanks. Yeah, so Space Systems Command is very focused on delivering resilient and sustainable capabilities for the joint warfighter, and launch is a really big part of that. We are seeing a really good variety of systems come out of industry. There's new options in fixed site, flexible site, and air launch solutions like Launcher 1, and it gives us a tremendous amount of flexibility and resiliency. The Space Force doesn't really have a preference from among those three options, but we're really excited to see Virgin Orbit expand its capability to launch from new sites beyond Mojave.
The motto for Virgin Orbit is opening space for good. Are there any aspects of the S-28 mission that you think really embrace that?
Yeah, so we are really excited about the things that industry is bringing to the table. And in large part, that's about capability, but it takes really good company culture to drive those capabilities forward. And so Virgin Orbit's motto is a good example of that. In terms of the individual payloads, so all 7 of the payloads on this mission are important to us, but I think the Slingshot 1 payload that we'll be flying is a great example. So it's a partnership between the government, the Aerospace Corporation, and industry. It's a larger 12U CubeSat, and it uses a kind of a plug-and-play standard interface to have a number of experiments on the same CubeSat. And it's advancing technologies from artificial intelligence to cybersecurity, really just across the board shows what we can do when we're all working together.
It's great, and 12U is one of the biggest satellites that we've launched yet on Launcher 1.
Yeah, so another great payload on this mission is the Nachos 2 payload, and it's studying gases in the atmosphere to look at phenomena ranging from volcanic eruptions to climate change. So it's really interesting.
So, sir, how do you see the partnership between Virgin Orbit National Systems, and the United States Space Force going forward in the future?
Yeah, so we are excited to be launching with Virgin Orbit today. Virgin Orbit National Systems is one of our 11 providers on our small launch contracts. And they really won the first competition that we ran on our OSB-4 contract, which was deliberately set up to bring in a whole crop of innovative new launch providers. And today's launch will be the first in a series of 3 launches. So we look forward to successfully completing all 3 of those. Beyond that, we tend to compete our launches one at a time, and I expect Virgin Orbit will continue to be a strong competitor for those launches.
We're definitely planning on it, sir. Well, thank you so much for your time, Lieutenant Colonel Belts. We're really happy to have you here.
My pleasure. Thanks, Danielle.
And back to you in the studio.
Thank you so much. Stay tuned for more customer interviews coming up, but in the meantime, we polled our audience on Instagram and Twitter and asked what questions you had about our rocket launch. We're going to hear a few of those questions now. Alex, do you think you'd like to take a stab at the first question?
Sure, yeah, let's do it.
Okay, great. Our first question is coming from Cooper in Los Angeles, California.
Why do we need more satellites? Why can't we just use the ones we already have?
Hey, Cooper. So we want to put more satellites in space to make life better here on Earth. So newer, more advanced satellites could do things like maybe track a wildfire live, track the weather, track climate change, or provide faster internet, better communication. The new idea now is to send up cheaper, more advanced, smaller satellites into a low Earth orbit. They actually won't stay in that orbit very long. They'll enter in a few years, and then we can replace them as needed. But it's almost like, you know, keeping a cell phone for 10 or 15 years or getting a new cell phone like every 2 years.
Amazing. I think I need a new cell phone. Well, thanks, Alex. Let's hear another question from our audience. And this time, let's have that answered by a special guest.
My name is Rai. How does a big rocket fit on a plane?
Hi, Rai. That's a good observation. Rockets don't usually fit on the airplanes we fly on. We had to do a lot of work on our Cosmic Girl airplane. We installed an underwing pylon so the rocket doesn't travel inside the plane but on the outside below its wing. And we give the rocket a ride to the sky. Then we release it, and then it turns its engine on, and then it flies to space at 17,500 miles an hour.
Hey y'all, this is Keith back with an update from MCC. As you can see, Cosmic Girl has pulled away from the Hammerhead. The Hammerhead's the name of the area that we stage all of our trailers and do all of our loading at. She is getting prepped and engines are starting to be turned on at this point. So we're getting real close to takeoff. That's it for now.
Expected warning on S1 locks fuel DP.
Wow, everyone, this is super exciting. So obviously, as you can see, Cosmic Girl is going out to the runway, and she should be taking off very soon. When we had that backside view, you could see her checking all the flaps. You can see her checking the tail flap, so that was super cool. So we're going to both watch and listen as she makes her way out. And so just a reminder, the takeoff time as it shows on the screen is expected for 10:50 p.m. And then it will take about 69 minutes, so just over an hour to get to the drop point when she does that.
That's such a beautiful shot, watching Cosmic Girl taxi over to the runway.
And this is our first time seeing it at night. So just to tell you a little bit about what's going to happen once she is up in the air, there's a couple of things that I'm going to want you to listen for. So like again, like I said, it's going to be about an hour to get to the drop point. But as she gets out there, you're going to hear the pilot. We'll probably have the audio from the plane. She's going to say she's doing the cold pass. So that means we're getting to the drop point, but we're not going to actually drop the rocket. We're just going to make sure all systems are still go, make sure the ground antennas can still receive and track the telemetry. Then, while still in this racetrack pattern, I'm just pausing here for a second to watch her. We're going to hear her say terminal count. Terminal count is like 15 minutes to drop. Okay, here we go. This is awesome.
Wow.
Wheels up. So Cosmic Girl is on. We are on our way. All right.
Wow.
Excellent. Awesome. Okay, so as I was saying, so it's about an hour to get to the drop point. And when she's out in that drop point, we're going to want to listen for what we call terminal count. That means we're approximately 15 minutes away from dropping the rocket. That's where we're getting the stage 1 engine ready to start going through a sequence of events to get that ready. And then you're going to hear a call from the crew for drop ready. And then drop ready mode lasts the maximum 90 seconds. So within those 90 seconds, we're going to drop the rocket and we'll hear release, release, release. So our plan is to have the audio from the aircraft on at that time so that we could hear that from the pilot. I was doing my
Operators, see in control room, health checks for terminal count are set. LCC evaluation will begin once Cosmic Girl is over water.
Now, in case you're wondering what you're looking at there, we have a camera. We have a few cameras on the rocket. We have one camera that's facing back, like towards the back end of the rocket. But because we're attached to the wing right now, we're seeing what Keith described as the pylon that's holding the rocket to the wing, and then above at the top is the wing of the plane. We will on and on have the mission control audio on, so you might have heard them already talking about terminal count, although it'll be some time before we get there. But what a great shot. I'm happy to see that. All right, so now that our aircraft's up in the air, it's probably a good time to tell you what exactly is going on or what she's doing right now. So I'm going to describe the flight path that she's taking. So as we mentioned earlier, everything was at the Mojave Air and Spaceport. And so Cosmic Girl just took off from that runway out of Mojave Air and Spaceport. So she's going to fly a flight path that we've carefully coordinated with the FAA just because we have a loaded rocket attached. And then she's going to go into what we call a racetrack pattern. So in that racetrack pattern, she's going to first start off by going to the cold pass. That's where I mentioned we pass the drop point and just check everything out without dropping the rocket. But then we'll go to that drop point again, and it's called the hot pass. And that's where we'll actually drop Launcher 1. And so that's what we're heading our way down to do right now. So super exciting. Before we do that last turn on the last pass, we'll go into terminal count, so you'll hear that. So listen for that, and then we'll go to drop ready. As soon as that rocket drops, there's a little bit of a delay before it ignites. Cosmic Girl will bank a quick right turn, and then she'll return to Mojave pretty much at the same path that she came out from. So let's now switch over and tell you a little bit about our pilots. Allison?
Absolutely. So we actually have 2 pilots aboard Cosmic Girl this evening. Our chief pilot is Eric Bippard. Eric has been flying since 1986. He's logged over 4,800 flight hours and over 1,000 flight test hours. If you want to play along at home, his call sign is Bip. And in the second seat, we have Matthew Stannard, who is the Royal Air Force test pilot on loan to us this evening. He's been flying since 2006, has over 3,000 flight hours and over 200 flight test hours. His title is Flight Lieutenant.
Radio headroom control. Long Beach has acquired target lock and fencing.
My name is Bodie, and I was just wondering, how high does your rocket ship go?
Well, that's a great question, Bodie. Our Launcher 1 rockets fly to our planet's orbit. It can go up, 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 as high as 745 miles from where you are now.
Shed on control, stepping on further.
Next up, let's hear about some of the satellite payloads we'll be delivering tonight. First up, we have Gunsmoke L, which will produce 2 tactical space shuttle support vehicles, which will aid in all phases of Joint Force operations. Second, we have Modular ISR Satellite, a program intended to demonstrate responsive multi-mission CubeSat capabilities. The MIRSB CubeSats are the second in a series of missions to demonstrate various capabilities and mission effectiveness. And third, we have Slingshot 1, which is a program developed by the Aerospace Corporation to use a commercial 12U CubeSat as a demonstration platform for the use of new modular technologies to speed up system development, allowing for faster information. Now, we'll get back to some of the more payloads in a minute, but let's dive back into what inquiring minds want to know. Our next audience question is from Haley in Pacoima, California.
My name is Haley. My question is, when you send rovers up into space, how do you keep them from floating away forever?
Wonderful question. Well, Earth is a lot bigger than our satellites, so its gravity has a strong pull on them, and that is why they don't fly away forever. Since Earth spins, it pulls the satellites with it, and this allows them to stay above the same spot on Earth almost constantly.
Hey all, I'm back with a quick update from the MCC. We are currently reviewing all the data from Launcher 1, and the operators are judging it and assessing for stepping into terminal count. So that's going to be going on for a little while now while we proceed and approach that gate. So with that, let's take a look at some of the data the operators are reviewing by taking a look at our data GUI. So as you see across the top, we do have the Launcher 1 vehicle. We have stage 1 on the left and stage 2 on the right. All the tanks are fully fueled and loaded up as we expect for being in flight. What you see next is our Newton 3 aux pump temperature. It's really important that we chill this down before flight to actually get it matching the liquid oxygen temperatures that are going to be flowing through it. So that all happens when we're in terminal count. So you're going to see that it is still sitting really high up at like Mojave temperatures. But once we start terminal count, it'll start being chilled down and getting into range. Next, you see the stage 1 propellant temperatures and pressures of the tanks. Those are reading as we expect for this part of the captive carry profile. Similarly, we have the interstage temperature reading within expectations and the separation bottle for separating the two stages. Pressurized as we expect for when that kind of separates the two, pushes them apart. Stage 2 is reading with inbounds as well for temperatures and pressures. And then the payload is still sitting in a very comfortable temperature to keep all of the sensitive and satellites set. Our bus voltages are reading with inbounds as expected. And Cosmic Girl is up at that 30,000 feet flight level, cruising along. The pallets are pressurized or loaded still, and the pylon is properly pressurized, holding Launcher 1 attached as expected. So with that, we will take a quick break.
Hello, Sadie and Cora. The rocket goes very, very, very fast indeed. Its maximum speed is 17,500 miles per hour, or 28,163 kilometers per hour. It must go this fast, otherwise it gets pulled back to Earth by gravity.
Operator, CEO, controller, commit to terminal account LCC gate is set. Begin evaluating your LCCs. Polling will occur prior to the cold pass and the drop point. Please come to RPG within the next 10 minutes.
Welcome back. So as we're waiting for Cosmic Curl to get to that drop point, we want to tell you a little bit more about the payload. So another payload on our vehicle today is called the Compact Solar Total Irradiance Monitor, CSTIM. So this one is a 6U CubeSat. It has specialized sensors and instrumentations to measure the sun's energy entering the Earth's atmosphere. So given that the sun is our predominant energy source, I could see how we can get a lot of useful data from this. So a very interesting one there too. Another one is GPX2. So this is a technology demonstration of differential GPS. So differential GPS uses both GPS satellites and ground station satellites on the ground. And it's set up to significantly increase the accuracy of the GPS. I did wanted to add a little bit too, and you might have heard a little bit when Lieutenant Colonel was talking, but this mission is also known as STP-S28A, STB being the Space Test Program. And it was awarded to Virgin Orbit via a subsidiary, Virgin Orbit National Systems. They actually won a contract with the U.S. Space Force on their Rocket System Launch Program, or RSLP, which is part of the OSP-4 contract. So I just wanted to add that. I know the Lieutenant Colonel had mentioned it earlier, but I wanted to mention it again.
Thanks, Alex. Now, in addition to our 2 pilots, we also have 2 additional flight crew aboard the plane. Do you want to tell us a little bit more about their roles?
Yes, so we do have 2 launch engineers traveling on the plane. They're on consoles with their computers and checking the status of the rocket. So Sarah Barnes and Dale Alexander. And so they're flying there with the 2 pilots.
Amazing. And it's going to be very different. Is there one certain aspect that you are most excited to see tonight?
Again, just those satellites getting in orbit. But right now, we're looking for getting to the drop point. And when that happens, everything's going to be really quick. So right now we're waiting, and maybe kind of like getting impatient, like let's get there. But once it starts going, it's going to be fast. So, and I want to do a quick shout out. So we've had our sign language interpreters here, Brian, and the other interpreter, Chris. So I'm very impressed that they're, keeping up with us with all of this tech talk. So I appreciate it, you guys.
Thank you so much. Great. Well, we'll be right back. Thank you.
LCC on control room. MCC is go for terminal count.
All right, so welcome back. We had some cool shots there of the pylon and the rocket again, and we very quickly saw a little animation of where our aircraft currently is, so we should have that back up again. I want to tell you a little bit more about a couple more of our payloads that we have tonight, or our satellites. So another one is called Nachos 2. You would have heard the Lieutenant Colonel mention that one. So Nachos 2 is going to measure dilute gases in the Earth's atmosphere to kind of track things such as volcanoes and climate change. So as the name implies, it's the second of a series. So there's a Nachos 1 and then there's a Nachos 2. And so part of what they're also going to do is see how these two satellites can work together to collect this kind of data. Another satellite that we have going up into orbit today is called Recurve with our Air Force Research Lab. So it will demonstrate adaptive radio frequency capability from low Earth orbit platform. So basically using RF antennas to talk to the satellite from the ground. So some good tests and experiment that we can do there. Now our current flight today is actually very similar to our last flight, Flight 4, that we called Above the Clouds. It was also a 500 by 500 kilometer orbit to a 45-degree inclination, as I had mentioned earlier. So let's go ahead and check out this video with a little bit recap of that flight.
The morning of is an interesting thing. You're very excited, there's a lot of anticipation. There's a big element of trust and reliance upon the people who've built the rocket.
Ground on control, S1 LOX load is complete.
Copy that, and looks like Auto 88 S2 LOX system chill has begun.
It's not uncharted territory anymore. We know what we're doing, we've done this before, we're getting confident, we feel good. Your imagination kind of stops, you go into muscle memory, and then you deliver.
LD comms check plane Honeywell.
Good morning, you ready to launch a rocket today?
Ready to launch a rocket today.
I got the update from Chase. They're in the racetrack. Clouds are from 30,000 feet up to 34,000 feet, all through the racetrack. It's a solid cloud deck.
Orbit base, LE1, are you go for takeoff? Orbit base, LE1, clouds and girls, airborne.
Copy, airborne.
Orbit base, closing 01, we are in clouds at 17,000 with a hold G into 20,000. Yeah, be aware there are multiple layers of clouds out here. We're in the clear at the moment. I expect to go back into it in the racetrack.
5, 4, 3, 2, 1. Terminal count initiated.
Cosmic L, accelerate.
Orbit base, LE2, rocket is on internal power.
Vehicles and drop ready, bud.
Copy, drop ready.
Release, release, release. Good light.
You know, as I'm doing this right bank, I look out my window and I see this bright plume with this rocket, you know, just shooting into space, and it's a pretty awesome experience.
Looks like we made it above the clouds and onward to orbit. Ah, it's a beauty up here.
Orbit base, closing out. We're expected on the ground 2335.
It was fantastic today, though, to show the capability we've got that we can get through that inclement weather, get the rocket to somewhere nice to be able to launch it, which was, you know, showing the capability that the aeroplane's got, which was great.
Hey all, welcome back. I do have some updates from the MCC and Cosmic Girl. Cosmic Girl is reporting that everything is nominal as expected, and the MCC has worked through its terminal count checks and verifications to make sure that we are good to step into that operation. That should be coming up at about 17 minutes to drop. That will step into terminal count. And then additionally, we have gotten verification that we are receiving telemetry from our Long Beach headquarters, which we transmit to as we get closer to the drop point. So that's all going forward nominally and as expected. So now let's take a chance to look at the rocket flight profile that it's going to fly after Cosmic Girl drops it. So Cosmic Girl will drop it at 35,000 feet. We'll then, 5 seconds later, ignite the Newton 3.1 engine. That'll power us for 3 minutes to get us to our main engine cutoff point once all the propellants are gone. We'll then do stage separation and let Newton 4 take over and start powering the remainder of the vehicle for the next 6 minutes until we get to our second engine cutoff point, which we will then be at 170 kilometers up above in altitude. We'll also now be in a transfer orbit that is going to let us proceed around the world and gain altitude on the way. As we do that, we're going to rise up to our 500-kilometer target for deploying the payloads. We're not done quite yet, though, because we have to do a second burn of our Newton 4 engine to circularize at that orbit. So we raise up to a 500 by 500 kilometer orbit. We'll then move forward and deploy the payloads, and after that, we'll then be done with our mission, and we'll have mission success. So that is the profile, and with that, I can hand it back to Allison.
Amazing, Keith. Thank you so much for breaking that down for us. Now, can you tell us a little bit about what we might expect to see this evening?
Yeah, it's actually pretty exciting because this is our first time doing a night launch. So when we look at the video from Launcher 1 as it's flying through Stage 1 flight, we are going to be seeing probably a much larger and brighter plume than we normally see. We're also, as we get higher up in altitude, we'll probably start seeing the lights of Los Angeles in the distance. And I do believe that if you're on the beach in the Southern California area, you may be able to see us flying out in the distance, low on the horizon.
So if you see an unexpected mark in the sky, that just might be Virgin orbit tonight. But make a wish anyway. Well, this is very exciting. We're getting really close to drop right now, so we'll be back in a few moments. Welcome back, everybody. Now, you may be wondering why we've named our missions Straight Up. Well, that's because here at Virgin, we name each of our missions after a hit album from Virgin Records. Our first commercial launch was Tubular Bells, named after Mike Oldfield's 1973 debut album, which was also the very first release on Virgin Records. And then our second commercial release was Above the Clouds, which was named after the 1998 Gangstar album. Now, this time, we are paying homage to American singer Paula Abdul and her breakthrough hit, Straight Up, from her album, Forever Your Girl. Yes, all right. Hey, baby. Okay, all right. I promise no karaoke in the studio, but after the live stream, it's go time. Now, last week was the 34th year anniversary of the album's release. Paula, we are huge fans over here at Virgin Orbit. Thank you so much for inspiring this mission. And now for a surprise video from the legend herself.
I cannot believe that the day is finally here. Close to 2 months ago, I got a phone call that Richard Branson wanted to name his next orbit shuttle Straight Up. And here I am in the Mojave Desert. I got to see the Straight Up shuttle that's going to be dropped tomorrow night. It's the first ever evening flight, and it's going to be, if you're by the ocean, between 10:45 to 11:45, you will probably see it. I can't believe it's called Straight Up, Straight Up, Straight Up. Oh my God, I'm freaking right now, and I'm here just seeing all these geniuses do what they do best, and my hat goes off to them. It's fascinating what I've learned so far, and let's go take a look. Let's go take a look at the Straight Up orbit shuttle.
Base tracking, no issues.
Copy, tracking, no issues.
Hey all, quick update from MCC. We have started our terminal count procedures. These are basically what we run to cool down the engines and prep them for actual launch. So everything's moving forward, and we're proceeding nominally and as expected. So with that, we'll go back to video.
Cosmic ground orbit base, tracking no issues.
Copy, tracking no issues.
Hi, I'm Owen. How do you keep communication with a rocket when it's moving every 20 feet?
Owen, that's a brilliant question. The rocket moves very fast, and the Earth itself is moving fast as it spins too. And we have satellites here on the ground all over the world so that our communications with the rocket are always covered.
Okay, so a lot of exciting things have been going on in the last few minutes. So you kind of tell from that graphic that it's in that racetrack pattern. It already passed the cold pass of the drop point, and as you heard, we're in terminal count with about 9 minutes left to the drop time. So when we drop, a lot of things are going to happen really fast. So I want to kind of describe it now, because we'll have the mission control audio on so you can listen, and then we'll recap after, but I want you to know what to listen for. So obviously you're going to hear release, release, release. And so that's when the rocket is dropped. And then the propellant selling thrusters, or PSTs, are going to ignite. So you'll probably hear PST2 ignition. And then you're going to hear main engine start. And then you should hear a call out for max alpha. That is the most difficult part of the trajectory of our flight to control. So we definitely want to hear that we've gotten through max Q alpha. And then the next thing that we're going to hear is, well, that was max alpha, sorry. The next thing we're going to have to hear is max Q alpha. That is the most stressing part of the trajectory. That's where most of the forces are on the rocket. So we want to hear, hey, we've gotten through max Q alpha. Then we're really getting up there, and we're going to eventually get to down throttle. So listen for a call out for down throttle. That's when our sense acceleration is 5 Gs. And we didn't want our satellites to sense more than that. So then we down throttle our thrust to a lower state point level. And then very quickly after that is going to be main engine cutoff. And we'll be coasting for a little bit, and we'll separate stage 1. So hopefully we'll be able to see our aft cam on the rocket and see that really bright plume that Keith described and see the separation event itself. So pretty soon we'll turn up that audio on that mission control, and we'll listen in. So next we want to listen for drop ready, and then we're going to want to listen for release, release, release. So we'll be right back with that. Thank you.
Cosmic Girl orbit base tracking no issues.
Copy, tracking no issues. Orbit base, Cosmic Girls rolling out, inbound turn hot pass.
Base copies, inbound hot pass.
S1 propellant tanks at expected pressures.
Cosmic Girl orbit base, the S1 tanks are at expected pressures.
Copy, S1 tanks at expected pressures. For base accelerating.
Base copies accelerating.
Battery power is enabled.
Orbit base, LA2 vehicles on internal power.
Base copies on internal power.
Orbit base, LA2, aircraft S-band and AFSS confirmed go.
Base copies confirm go.
Like I mentioned earlier, we were turning up the audio on mission control, but actually that's the audio from the aircraft itself. So you've been hearing the voices of Sarah Barnes and Dale Alexander. And I've heard the pilot.
Engine chill nominal.
So let's listen in.
Newton 4 NG till nominal.
So every time you hear nominal, that's good. That's as expected, which is awesome.
LV, radio head on control room. S-band lock acquired in Long Beach.
Copy, S-band lock acquired in Long Beach.
Hey, good news there. So our antenna on our Long Beach antenna has reacquired lock. We knew that there was a bit of a blockage from some hills in the area, so it's nice to get that back. Having that telemetry is what allows us to get this video, for example, the one right here showing them.
Or base vehicle is in drop ready mode. Base
Oh,
copy,
excellent.
vehicle
Drop
in
ready mode. So we're dropping in like 90 seconds max. Let's listen in.
Well, start warning. Release, release, release.
Yes.
Confirmed release.
That.
Base copies.
Switched
Good light.
Saldita to S-band from
Base
Long
copies.
Beach.
Good
PST's
light.
ignited.
Newton 3 startup complete.
She's saying it. We sent it. Or launcher one's going straight up to space. Base copies. Well done.
Incredible job, Ellies.
Awesome. In the studio,
Max
can we
Alpha flight
switch over
complete.
to MCC audio?
Stage 1 burn nominal.
Max Q Alpha achieved.
All right, so we kind of switched between the plane audio and then the mission control, but I heard the call out for Max Q Alpha. So that's a huge milestone during stage 1. I also heard a call out for propulsion being nominal. So that is fantastic, and what I can see on the video looks great.
Stage 1 PU nominal, halfway through burn.
Okay, so I just heard halfway through burn and still continuing nominal, so that's all as expected. This is fantastic.
Stage 1 burn nominal.
So we're waiting to hear next is going to be down throttle.
Stage 1 trajectory nominal.
And main engine cutoff. And now that was a call out from our guidance navigation and control engineer that GNC was nominal as well. So nominal propulsion, nominal guidance navigation and control. It's amazing to me to see this video coming down live.
Newton 4 chill nominal.
That was a call out that stage 2 chill is nominal because that will ignite as soon as, well, closely after stage 1 burns out. If you recall, I said stage 1 will burn for approximately 3 minutes, and we're currently on a 2-minute and 30-second count.
Stage 1 throttle down commanded.
Okay, so there was down throttle.
S-band lock for Baja TM, data confirmed.
And we're definitely getting higher in the sky.
Newton 3
that's
shutdown confirmed.
Engine shutdown.
Stage 7 brake wire is broken.
Okay, stage 1 has separated.
Newton 4 started complete.
Okay, so that was a call out that Newton 4, stage 2 has ignited. Fantastic.
Switch to S-band from Baja.
So now what you just heard is our antenna that's in Baja, California, is now what's picking up the telemetry data. Long Beach also can still see it, but Baja is going to be the one that sees it longer, so they switched over to it.
Fairing brake wire is broken.
Okay, I was about to say we're listening for fairing SEP, and there goes the fairing. So as expected. This is excellent. This is awesome. Right now, this is camera forward. You could see it at the top. Now, when we get to the other side of the world, we would have sunlight, but because it's night, we don't have any lights up on the front, and we don't have the plume from the stage 2. The cameras will switch back and forth between forward and aft. So back to the aft, showing the stage 2 plume. Yeah, if you just look at the top, it says, for example, camera aft. That means it's looking at the back end. So if you see it switch to forward, it's looking forward. It's just very dark right now, so we won't see much on that one until later.
Stage 2 trajectory nominal.
Excellent. Stage 2 trajectory, as expected, nominal. So this burn, so the timer there is from drop. So this burn ends approximately 6 minutes after drop, which would officially put us in our transfer orbit. You'll hear a call out for second engine cutoff, number 1.
Stage 2, burn nominal.
Yeah, take a look on the left-hand side there. We have rocket, we have speed. We've got altitude going up, up, and up. 569,000 feet. What, 10,000 or so?
Stage 2 PU nominal, halfway through burn.
Okay, trajectory still nominal, halfway through burn. So when it gets to second engine cutoff number 1 right now, we're going to be in an orbit that is 177 kilometers by 510 kilometers. It's our transfer orbit. And then we're going to coast for about 45 minutes to get to that higher altitude.
Stage 2 burn nominal, 2 minutes until SECO.
All right, I kind of talk over it a little bit, but continue to be nominal. And they called out, I believe, 2 minutes until second engine cutoff. Or SECO. Look, I'm so excited right now that I can't even believe it's 12 a.m. I don't even feel a peep of being tired.
And our speed is increasing quite a bit.
Yes. Oh, yeah. And the altitude.
What max speed will the rocket go to?
So for the end of stage 2, 17,500 miles per hour. So currently at 14,000 miles per hour.
1 minute to SECO.
1 minute. Okay, cool. Excellent. Now, when
30 seconds to see go.
Okay, I'm just going to listen in.
AFSS mission rule satisfied.
Hotline to LD on control.
Newton 4 shutdown confirmed.
Excellent.
Hotline to LD on control.
Go ahead.
Permission to release the airspace since we've satisfied all AFSS requirements.
Permission granted.
Copy, thank you.
Excellent. So what we just heard was that second engine successfully shut down. That means the guidance navigation control determined that it had reached the transfer orbit and shut down the engine. We will very quickly right now go out of view of the Baja antenna, and then we'll be black in terms of telemetry coverage
Go started.
or videos.
Barbecue roll started.
Or anything like that. You might have heard Keith describe the barbecue roll in his descriptions trajectory, so that's what it's doing now. So it's going to start rotating the rocket very slowly with an orientation such that when it gets on the other side of the world and the sun's hitting it, it's going to be perpendicular to it, and then we're just going to try and balance the temperature on the rocket. So very exciting. So we've officially reached our transfer orbit. I'll see if I can get some details about the orbit. So I think with that, we'll just confirm some of the data, and we'll come right back.
See on control and stepping off for 5 minutes.
Copy.
Plan on control stepping off for 5 minutes.
Expected loss of S-band signal from Baja. Final loss of target lock at Baja. Next expected target acquisition at Artemisdock.
Thank you so much, Alex, for that play-by-play. Now, here at Virgin Orbit, our first mantra is do no harm, which is why our recycled and repurposed 747 Cosmic Girl prevents the need to build out new launch pads, and instead we can launch from any runway at any time. And because we launch in the air, we emit 90% less carbon onto the ground area as compared to ground launches. And the small satellites we launch help monitor things like climate change and study the Earth, helping to further our mission to open space for good. So to put things in perspective, Virgin Orbit's total impact in 1 year is still less than 1 hour's worth of flights out of LAX. That really gives you perspective on that. Next up, Virgin Orbit branches into new territory as we prepare for our first international launch. We'll be launching out of Cornwall, and this will be the first ever orbital launch out of the United Kingdom. So it's going to be very exciting. We'll be back with you in just a minute. Thank you so much for joining us on today's live stream. Please make sure to follow Virgin Orbit on social media for continuous updates on our successful satellite deployments this evening. We're at Virgin Orbit on Twitter and at virgin.orbit on Instagram.
Excellent. So just one other note, we officially made it to our transfer orbit, but we're not done yet. So we actually have to get to the target orbit to deploy our customer satellite. But that is going to be another 30 minutes. And so like Allison has stated, we're going to be ending our public broadcast now, but make sure to check our social media posts to see the final conclusion to our mission today.
Very exciting conclusion. We want to thank everyone who tuned in live to watch our Straight Up mission today. We also want to thank all of our customers for flying with us. And a special thanks to the live stream production team, the brand team, and of course, my brilliant co-hosts, Alex and Keith. We look forward to seeing you next time in Cornwall. Bye, everyone.